Let's talk about a different type of problem. And we notice our denominator looks a little different because it's going to have a plus or a minus in the denominator with a square root. We have to do this a little differently because of the fact that we have an add or subtract. So instead of just multiplying it by the square root of 2 over the square root of 2, because that wouldn't do me any good, if we go in the bottom and just think, well, what if we multiplied that by the square root of 2? Well, I would distribute, right? Take that times both of those, and that's the square root of 2 plus 2. So I'd still have a square root. So we're going to do it slightly differently. Since this is a plus, I'm going to rewrite it with a minus. And since I put it in the top and bottom, I'm still just multiplying by a 1. We know that this fraction equals a 1. And you want to think, man, Mr. Repka, why does that help us? Well, let's go down to the side. If we do 1 square root of 2 times 1 minus square root of 2, I have to FOIL. First, 1 times 1 is 1. Outer, 1 times negative square root of 2 is negative square root of 2. Inner, 1 times positive square root is positive square root of 2. Last, positive root 2 times negative root 2 is just negative, we could call it square root of 4 for right now. We notice the middle terms cancel, and I get 1 minus, what's the square root of 2? The square root of 4? 2. 1 minus 2 is just negative 1. And this will always happen when you do this with this way. This is called the conjugate. When you multiply by the conjugate and you FOIL, your outer and inner terms should always cancel. Your last term should always be something we know the square root of, and we will get a regular number. Now on the top, we just need to distribute. 3 times 1, 3 times negative root 2. So 3 times 1 is 3. 3 times negative root 2 is negative 3 square roots of 2. We could leave that negative in the bottom, or we can change the sign of everything on top and put negative 3 plus 3 root 2. It's up to you. I would be fine if you just left it right there. 4 over 2 plus square root of 3. We're going to multiply by the conjugate, which means we'll change that add to subtract. Off to the side, we're going to have to do some FOIL. First is 4, outer, inner, last. Outers and inners cancel. 4 minus 3, that's just 1. Oh man, that makes it easy. Distribute the numerator. That's 8 minus 4 square roots of 3. As you get better at this and you do your FOIL, you might as well just skip the outer and inner, because I just said they're always going to cancel. Let's do 7 over 1 plus the square root of 6. Can you go ahead and finish it on your own? 1 minus the square root of 6. Again, we will need to FOIL. I'll just do the first and the last. That's just negative 5. Distribute the top. 7 times 1 and 7 times the negative square root of 6. 5 divided by 4 minus the square root of 7. Well, our conjugate now just has a plus. 4 plus the square root of 7. Come down to the side and FOIL. 4 times 4 is 16 for my first. My last, again, I'm not even going to do the outer inner. So that's 16 minus 7, which is just 9. So my denominator is 9. My numerator, be sure to distribute, is 20 plus 5 square roots of 7. Let me do a hypothetical. We know this is our answer for this problem, but what if our answer was 20 plus 5 square roots of 7 over 8? Can I reduce that in any way? Does this reduce in any way? And hopefully you're saying no. Because of the plus, we can't reduce part of a plus and minus in a fraction. So this would be our final answer. If I tried to really trick you up and make it a fraction like this. Let's do 4 over the square root of 2 minus the square root of 5. Well, Mr. Repka, we've been doing problems with plus and minuses in the denominator, but we've only had one square root. Now we have 2 square roots. I would tell you that the process doesn't change. Just change that denominator to a plus. Because what happens when I FOIL the denominator? My first becomes square root of 4. Outers and inners will cancel, and my last becomes square root of 25. That's 2 minus 5, or negative 3. And what have we been doing in the numerator? Making sure we distribute 4 square roots of 2 plus 4 square roots of 5.